Hey folks, Mr. Dell here. We are looking at the finding a area and perimeter given kind of a composite figure of algebra tiles. So this is a problem from CPM's course 3, CC3, and section 5.2.2, specifically number 5-37. So it says examine the rectangle formed with algebra tiles at the right. Just to review algebra tiles, remember algebra tiles? I'm going to just review it real quick. You have three main tiles. There's the x squared tile, which is the x by x. Then there's the x tile because it's a 1 by x, so we call it the x tile because that's the area is x. The area here is x squared because it's x times x. And then there's the single ones tile, and its area is 1 because it's a 1 by 1. So those are algebra tiles, right? So these are algebra tiles that we've dealt with in the past. Okay, so this is a shape that is made up of algebra tiles. So there's an x squared tile, 3 x tiles over here, 2 x tiles over here, and then 6 ones stacked together to make this rectangle. So first of all, it says to find the area of the entire rectangle. Remember, the area of each rectangle or each section is already listed here, right? So the area of this is x squared because it's x by x is the dimensions. The area of the rectangle is x because the dimensions are 1 by x, right? And then each of the areas of the little squares are 1 because their dimensions are 1 by 1. So if we're talking about area, I can just add them all up. So I have an x squared tile plus 1, 2, 3, 4, 5 x tiles plus 1, 2, 3, 4, 5, 6 ones. So that right there is the expression that represents the area. I can't go any further than that because I can't combine x squared with an x. They're not the same, right? So that is the answer or expression for area on A. Okay, does that make sense? So then the perimeter is distance around. Remember, perimeter is if I'm going to walk all the way around the entire rectangle, how far would I walk, right? So what I want to do is label each of these pieces. I can see, like I said, those are x by x. These are ones. That's a 1. That's a 1. That's an x. These are all ones. That's 1, right? The distances are ones, and then the distance here is x. The distance on the sides are all ones there. So what is the perimeter, right? The perimeter would be adding all these sides up. I can say it's x plus 1 plus 1 plus x plus 1 plus 1 plus 1 plus 1 plus 1 plus x plus 1 plus 1 plus 1 plus x. Or I can do some combining like terms. So for perimeter for this problem, if I combine like terms, there's 1, 2, 3, 4 x's that are being added. So the perimeter's expression is going to be 4x plus, and then if I count all the ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4x plus 10, that's the expression that represents the perimeter because some are x's, some are single ones. Okay. All right, there we go.